constitutional isomers of the same chemical formula, structurally they're put together in different ways. The connectivity of the molecule is different. Because there's unique connectivities, it's actually going to give each of those molecules unique names. So base the name and how the molecule is put together. So 4 carbons in a row would be butane, but if our longest continuous chain in any direction is 3 carbons, then the core name of the molecule, 1, 2, 3, is based on propane. Now with a branch of the second carbon, so 2-methyl propane is the name we give to that second molecule. And this is the key method for realizing that we've got constitutional isomers. If you can give two or more molecules with the same chemical formula, if you can give them unique names, then they're constitutional isomers to each other. Different molecules will have different names. But if you can give 2 molecules the same name, then it must be the same molecule. This change in the structure has big considerations or big problems to the chemical and physical properties. Molecules can become very difficult to chemically react together if they're structurally put together differently. Because we're often looking for very specific functional groups in the molecule to be part of the collision and cause a reaction. If we change the structure, those molecules could become more exposed at the functional group or more protected in the functional group. That changes the chemistry. It's also going to change the physical properties. We said there's a fundamental idea of getting a solid to melt into a liquid is getting enough kinetic energy as we raise temperature to get the molecules to separate, to break down those forces of attraction. Those forces of attraction break down more rapidly if the molecules pack together less efficiently. So different structures and branching in the molecule makes the molecule less easy to pack together, so bonding forces are weaker and melting and boiling temperatures decrease. We go up to just 6 carbons, and we now have 5 of these constitutional isomers. We can give them all unique names to each other. First one, with the 6 carbons all in a row, of course it would be just hexane. Second one, the longest continuous chain of carbons, would be 4 of butane, which means we've got a branching from carbon 2, carbon number 3, 2,3-dimethyl butane. Next one, 1, 2, 3, 4, 5 carbons in a row. We've got methyl group in carbon number 2, 2-methyl pentane. Next one, 1, 2, 3, 4, butane derivative again. But this time the 2 branches, instead of on carbons 2 and 3, they're both on carbon number 2. So 2, 2, dimethyl butane. The last one, 5 carbons in a row again, like the third one. This time the branch is on the 3rd carbon in the molecule. Names must be unique. And as you draw those constitutional isomers, recheck them and look at the molecule from the other end. Have you drawn the same molecule twice and just drawn the branch at the other side of the molecule in the same position? So for example, well, this third example is 2-methyl pentane is not going to be a new constitutional isomer if we draw that molecule. Because we've moved the methyl group onto this carbon, now this becomes carbon number 1. So it'll still be 2-methyl, 1, 2, 3, 4, 5, 2-methyl pentane. So be careful about drawing the same molecule upside down or backwards, just flipped around in some way. there are 3 constitutional isomers for pentane. Take a second and try and draw those 3 constitutional isomers for pentane. The first one for pentane, the easiest is just those 5 carbons in a row. That's one example. Second one, let's shorten it to 4 carbons in the main chain. We'll put on a branch, we'll put it on the second carbon. Excuse me. Pentane. Constitutional isomer to methyl butane. And then the last one we can do, we need to change the connectivity of the molecule in some way. Now we can't just put a methyl group there because it's the same molecule. If you go through the numbering, that would now be carbon number 1, so it'd still be 2-methyl butane. We can take another carbon off the main chain and make it just 3 carbons in a row, and now put 2 substitutions on the second carbon. So it becomes 2, 2 dimethyl propane. Same chemical formula, connectively put together in different ways. Different ways which gives us different names for the molecules. Now be careful, one of the things that you can't do is just put 5 carbons into a cycle. Certainly differently connected or connectively different. But remember, every time we close a chain of carbons by forming a cycle, we lose hydrogen from the formula. So while the pentane here, it's 2 constitutional isomers, a C5H12, the cyclopentane would be C5H10. Different chemical formula. Our constitutional isomers must have the same formula. This is not constitutional isomer. Okay, just for fun, try some constitutional isomers for C4H9Br. Many as you can. We'll see if we can come up with less. So the simplest ones we can draw are going to be with 5 carbons in a row. We get a couple of answers based on where the bromine atom is. You could put the bromine on carbon atom number 1, make it 1 bromo butane. We'd also have bromine atom with carbon number 2. Make it 2 bromo butane. We try carbon number 3, and then as we give the lower numbering to the main chain, we'd actually have to start numbering from the right-hand side, so it'd still be 2 bromo. Again, rule number 1 is you're trying to spot check your work. Look for molecules which have just been flipped around or turned upside down. You can give a molecule the same name as one of your previous examples, and it is the same molecule. So that exhausts the possibilities with 4 carbons in the chain in a row. So we have to switch to having 3 carbons in the main chain. Then having a 2 methyl branch. So our bromo atom this time, we put it on the first carbon there. So making this carbon 1, 2, 3. So make sure you let yourself enough room. 1 bromo, 2 methyl propane. Now we could try putting the carbon in a different position. We put it on the bromine, on the carbon there, then this would therefore become the first carbon in the chain. Give us 1, 2 substitution, 1 bromo, 2 methyl, propane again, so that doesn't work. We could try putting the bromine atom, try putting the bromine atom up here. Again, that just makes us rethink the numbering of the molecule. This would be the earliest position of a branch. It still give us 1 bromo, 2 methyl propane. So what else can we do? Put it in the middle, yes. So, second example, with 3 carbons in the chain, take the bromine in the middle. So now as we name it, it's going to be 2 bromo, 2 methyl